FDOT Design Manual Training, FDM 202 Speed Management, presented by Dwayne Carver. Several changes were made to FDM 202 Speed Management for 2024. These include revising the C4 design and target speed range, aligning the target speed requirements to be consistent with FDM 201, modifying and augmenting the vertical deflection criteria, and a complete revision of Table 202.3.1. Each of these changes will be covered in the following slides. (202.1) Revised C4 speed range. In Section 202.1, the C4 speed range was changed in FDM 201 for the 2023 FDM, and this change was overlooked. So what we have here is really a housekeeping edit. As you can see in the text, that changed the C4 design speed and target speed range from 30 to 45 miles an hour to 25 to 45 miles an hour. This change was made actually all the way back in 2022 and had just been missed in this chapter. So for this year, we fixed this. It was really just a housekeeping change. It could have been should have been caught before, but it has been caught now. This ensures consistency between FDM 201 and FDM 202. Similarly, in FDM 202.1, we added that the target speed requirement is only for non-limited access facilities. This was stated plainly in FDM 201, but was not clearly stated in FDM 202. So this change, again, was a housekeeping edit. It was modified at the request of the districts just to ensure there is consistency between these two chapters. So that's all that was made there, and it's really just to provide that consistency. The following changes were actual changes to criteria for 2024. The first one that we're going to talk about is the modification to 202.3.8, which is a modification and also a change or augmentation to the vertical deflection criteria that are found in this chapter. These modifications were made based on reviews of raised crosswalk projects that we've looked at over the last several years. We also increased the target speed for vertical deflection from 25 miles an hour to 30 miles an hour. And we made these changes mostly to provide consistency with FHWA, but it also reflects FDOT's own experience with using these new types of devices on our roadways. We also added criteria this year for speed tables, and we'll talk more about where that came from and what that looks like now. And we added some criteria and concept drawing for raised intersections, which are related to speed tables, and we'll talk about that as well over the next few slides. So, increasing the target speed for vertical deflection to 30 miles an hour from 25 miles an hour. The way this used to work, as we said, you could use vertical deflection on roadways as long as you were trying to achieve 25 miles an hour or less. We did not really want you to apply those on roadways that we expected to operate at 30 miles an hour. However, and since the original rollout of this criteria, we've had more experience with these types of devices and determined that it would be okay to use them on 30 mile an hour roads. So if you're trying to get a road to 30 miles an hour, you can still use this vertical deflection devices. This is consistent with the language that's from FHWA as well, and it's consistent with the way the districts are actually using these devices, and we don't see any negative consequences of doing this, so we went ahead and made this change in the FDM. The next change we made was to add some criteria for speed tables. Now, we created the speed tables by modifying details in the developmental standard plan D520-030 for raised crosswalks. The reason for this was we were getting a lot of reviews for raised crosswalks, which are supposed to be used in a mid-block condition, which is kind of the way it's shown here from the standard plan. However, we were seeing that folks wanted to use these not just as crosswalks, but they really wanted to have more of a speed management device, but they were concerned about the effect that these would have on large vehicles, buses and fire trucks and things like this. Even though this speed table is wider than a conventional speed hump, it can create a bit of a rough passage for some types of vehicles crossing these things. And so the countermeasure for that was to use basically a wider raised crosswalk table, which we would call a speed table. So I'm trying to explain sort of how this is put together and how it works with the criteria that we have there. So the language says, create speed tables by modifying the details in Developmental Standard Plan D520030 for raised crosswalks. Extend the raised crosswalk surface to a width greater than or equal to the axle spacing of the design vehicle, and omit the crosswalk marking unless the speed table is also serving as a raised crosswalk. Well, let me explain a little bit what all that means. So what we want to do is increase the speed, and see if I can get the laser pointer here, increase the distance of this area here across. So as the vehicle is traveling across, this is the flat part. This is a ramp right here. This is a flat part, and this is the ramp down. So we wanted to increase the flat part here on the top to make a tabletop, a longer section, a speed table. And the way we show to do that is you want to take the, there we go. We want to take, these red lines represent where the edge of the tabletop would be for a raised crosswalk, is basically as wide as the raised crosswalk. You want to extend that tabletop out so that it's going to be at least as wide as the wheelbase of your design vehicle. So in this case, we're showing the design vehicle as a city bus, which has a wheelbase of 25 feet. So I would want this to be at least 25 feet, probably a little bit wider, to accommodate that vehicle. If you had a different design vehicle with a different wheelbase, you could use that. So maybe you're designing around a fire truck or something like this. City buses tend to be the most common thing that we're seeing. You'll need to check with your transit company locally and see what bus they use, but this is one of the city buses that's from AASHTO, and so we were using it for this example. So the idea is you want to extend this tabletop out so that it is at least as wide as this wheelbase, and this will provide a smoother crossing for that vehicle. You can omit the crosswalk marking if you are only using this for speed management. Now, if you are also using it as a mid-block crosswalk, then you can leave that marking in. It can be put in the middle, it can be put on one end or the other. You really have a lot of flexibility as to where exactly you would put that crosswalk marking. So just use your best judgment on that. I'll give you a little more of an example of what this would look like. So at the top here, you can see this is a speed table at the top, and the width of this table, or I should say the length really, along the direction the vehicle is traveling, this is the same as the wheelbase of the vehicle. And I want you to see, this is a drawing from AutoTurn actually, that shows the deflection of this vehicle as it crosses these different types of vertical deflections. So, and I want you to see the amount of deflection that takes place is relatively slim here as I'm crossing this speed table. On the other hand, if I'm crossing down here, if I'm crossing a raised crosswalk, you can see I get quite a bit more deflection in those conditions. So right here you can see the deflection is a little bit higher. And this is also, we wanted to illustrate this by showing you, we have a short movie. So grab your popcorn and we'll show you the movie. So this is a bus riding over a conventional raised crosswalk type design, and you can sort of see there's some up and then some down. Passengers riding on that bus are going to definitely feel that they're sort of moving in rapid succession in two directions. They're going up and suddenly they're going down and they're going up and down again. So there's a lot going on there. Now for the longer speed table where it's more like the wheelbase, what will happen is the front wheels of the bus will go up, the back wheels will be okay, then both sets of wheels will be on the speed table, and then the front and then the back go down. So it's a much smoother set of transitions for the folks who are in that vehicle. So let's see what that looks like. It's up All right, and that is a much smoother transition. If anyone who's ever been in a bus riding over something like this will appreciate that, or even in your automobile, if you've been on this, you can feel it. Certainly, fire trucks, emergency services vehicles, ambulances, things like this will appreciate this wider speed table approach. So, in places where you need it, we now have this speed table offered in the FDM as an option for you to use. You don't have to use it. It's an option. It's just one more tool in the toolbox. But in places where you feel like there might be some concerns with the raised crosswalk design for particular types of vehicles, we have this other option available for you. In the course of doing the reviews for the raised crosswalks, we found something was tending to happen over and over again, and that was that we were getting people getting designs coming in that were wanting to put these raised crosswalks at intersections. And so as you would approach an intersection, let's say from here, I would have a raised crosswalk, and then it would go down again, and then it would be kind of a flat intersection here. This was problematic because we wanted to avoid putting vehicles, particularly imagine a large vehicle like a bus or something maybe a little more unwieldy, like a large single unit truck or even a tractor trailer, in a situation where they're kind of turning in two planes at one time. So they're not only moving up and down, they might also be turning at the same time, which is what you can get into if you have one of these vertical deflections, raised crosswalks at an intersection. The preferred way to do that is actually just to raise the entire intersection. This is not a new technique. Raised intersections have been around a long time. You may have designed them before. The department, has them here and there. We've just never really had any kind of criteria for them or any kind of a standard plan. We still don't have a standard plan for them. That's because intersections are unique animals. Everyone's a little different. So we didn't necessarily want to be able to give you, or weren't able to give you, a standard plan for that. But what we could give you are some standard considerations to use every time you design one of these things. And then you, as the designer or the planner, you go out and you make your best effort at this and try to incorporate these concepts behind it. So we'll talk about what those different concepts are. But the notion is we want to avoid having vehicles going up and down and side to side all at the same time. So we want to raise the entire intersection rather than put a raised crosswalk at an intersection. And we'll call out these different items that the designers need to consider. So as you do the raised intersection, what we want to do is raise it up so that the crosswalks across the intersection are at the same level as the sidewalk. So that's one of the nice things for pedestrians. When you come to a raised intersection, you don't have to go up or down. You just continue, your same level that you were at on the sidewalk. So that's the height at which we want the raised intersection to be raised. It should be so that it's flush with the surrounding sidewalks. As you approach the raised intersection, you want to have a 1 to 12 ramp. This is the exact same ramp design that is in the raised crosswalk standard plan. So you can go to that standard plan and pull that ramp design out of there. That's the exact same one, and we want to have this on the approach and exit from the raised intersection. So that's kind of already there for you. If you need to know how to draw one of those, you can use that standard plan. One of the issues we've had is that as vehicles are making a right turn, let's say this vehicle here wants to turn and go this way, we don't want them cutting the corner and maybe chopping off the corner of this. And keep in mind, we are now raising them up, the vehicle up to where it's the same height as the crosswalk, so it'll be pretty easy to do that. A number of reasons we don't want that to happen. Could be pedestrians there for one thing. Also, we don't want cars, getting onto the sidewalk or something like this. So there's a few ways to address this, but the way that the department has determined would be best on our system is to use basically this is a raised and textured island of some kind at the corner right here. We're saying textured stamped concrete at this raised corner island. It could be something else. The important thing is that it has some vertical element to it and that it has some kind of texture to it, and it's a contrast so that pedestrians who are approaching it will see that there's something there, so that motorists who are turning across it will also see that there is something there, and everybody can see that there's something there, and avoidance is the notion. So This should have a flat edge so that someone who's using a cane, for instance, would be able to follow this along, and it would lead them out correctly to the crosswalk. So all those things kind of come together to provide a device that serves the pedestrians, as well as helping orient the motorists as they're making this turn and keeping everyone out of the middle of the intersection and onto the sidewalk if that's where they're supposed to be, or in the middle of the intersection if that's the vehicle. So use these raised corner islands to provide that function. Note that this may require some additional drainage inlets. So if you're doing a raised intersection, you're going to need to think about drainage clearly. A lot of times you'll find those drainage inlets right at the curb radius, and we actually want to push it back a little bit. Sometimes that actually works better. Frequently, where you have the two roads come together like this at an intersection, the drainage can get a bit awkward anyway, and so we've actually found this to be preferable in some situations as a drainage solution, but you will need to incorporate that into your plan. So if you're going to have to move an inlet, make sure you're aware of that very early on so you can make sure that that can happen and all the appropriate folks get involved in that discussion. The crosswalks, we are calling for 10-foot wide, high visibility marked crosswalks. It's the same kind of crosswalk you would use at a signalized intersection, and you would use that whether this was a signalized intersection or not in this condition. You do have to have the ADA compliant detectable warning strips in this location. This is helpful for, again, orienting folks who may have low vision or who are using a cane to know where the edge of the roadway is going to be, and so those are required still because this is a pedestrian crossing. And finally, there's a note here at the bottom, and this drawing is actually this is the new figure 202.3.4. This is actually in FDM 202. There's a note here that we recommend that the interior of this be colored a contrasting color. Now in the drawing it's shown this way just to make it a little easier to read the drawing. So you can see this is the raised part of it and this is the flatter, more conventional pavement part of it. It doesn't have to be this taupe color. Any color that is acceptable, or it doesn't have to be a color at all. You can do it without coloring it. We are recommending that it be colored for contrast to alert motorists as well as pedestrians or anyone else using the intersection that there's something a little different going on at this intersection. Work with your local government. They may have a specific way that they would like to have this done, and so this will be treated just like we would any other sort of colored asphalt or colored concrete application. The difference here is that the department has an interest in doing this, and so you'll have to work out the best way to do that. We're not really specific about what materials to use or how exactly that would be done. We're just recommending that it be colored if it can be colored, and it may present an opportunity to work with your locals for aesthetics or a community aesthetic feature type of approach. So again, that's just a note here at the bottom. It's a recommended but not required practice. Now, this is shown using single lane approaches. If you had multi-lane approaches, you essentially would use the exact same set of requirements here or recommendations. That would not change. Engineering judgment will be required when you do these. Again, we cannot give you a standard plan to do one of these things because every intersection is a little bit different, but you're going to have to put together different elements of designing a roadway and designing an intersection on your own to come up with the way that this would look. So for instance, we can give you a standard plan for that ramp that comes up and leaves the intersection. But as far as how exactly you do the detailing about the intersection with the curb radius and how exactly the drainage has to work and all those things, even the lighting, which there's lighting shown here, that doesn't mean you have to use exactly those types of aesthetic lamp posts. There may be something else that would be more appropriate for your local area. That is, again, up to you and your judgment as you are designing this. So there will be some engineering judgment required. There will also be some creativity required. This is, again, not something we can give you in a completely canned fashion. This is not a cookbook. You're just going to have to look at the different elements that are required and do some design and exercise some creativity in the construction and design of these things. All right, the last item we have to update you on for this chapter is for table 202.3.1. If you're familiar with this chapter at all, you may recognize, well, you won't recognize it now, you may have recognized how this table looked before. This table is located at the end of the section that describes all the speed management strategies, and what it does is it brings them all together in one table. We've had some complaints about that table in years past, that it wasn't necessarily the easiest table to read, and so we wanted to try to modify it a bit. This is to make it a little more consistent with the look of some of the other tables in the FDM. So let me kind of show you what this is actually explaining to you. It is consistent now. We want to make it more consistent with other tables in the FDM. The idea is to help you provide kind of at a glance which strategies and target speeds and context classifications would sort of go together. So let's say, for instance, that we know we're in a context classification C4. This might be a general neighborhood context classification somewhere in one of our cities. We know that we're trying to achieve a target speed of 35 miles an hour. And so then which of these different strategies that you see at the top here will be most appropriate to use in a C4 trying to reach 35 miles an hour? And you can see as you look across the page here, all those X's are indicating those would be your first kind of go-to options to use those techniques there. Now, there are other techniques that are listed that maybe you would not use, would not be favored right off. You may determine on your project you actually do need those, and there's ways that you can get those, but this is to give you an idea right up front which sorts of techniques would be appropriate in these different locations. So hopefully you'll find this table easier to use and to read than its previous incarnation. We appreciate any feedback that you might have on it as you use this table. A couple of footnotes. In the original table, the one that was in the 2023 and previous versions of the FDM, there was rows in there for C1 and C2 context classifications. Well, here's the thing. The C1 and C2 context classifications on the state highway system are high-speed conditions. 55 to 70 miles an hour is the design speed for those roadways. We really don't use speed management when you're trying to achieve those speeds. At those speeds, you're kind of going in the other direction, and you're trying to make the road as safe as possible for the highest speed that you can design for. So we really didn't think that was appropriate to have C1 and C2 in this table, because really, in fact, all it said was if you're doing those, go look at FDM 210 to see how to design it. It really didn't have anything helpful to tell you anyway. So we just took those out, and that gave us a little more room to put the other information in there. And also for the C3R and C3C, those context classifications also have the possibility that you could be using a higher speed, up to 50, 55 miles an hour in some of those situations, and so we don't have that in here either. Again, once you get up to above 45 miles an hour, you're not going to be using speed management anymore. You're going to be designing for high speed. And so those are kind of two different worlds that you'll be working in. So this is really only going up to that 45 mile an hour in the C3 conditions. And that concludes the presentation. Please reach out if you have any questions about this information. Here's my contact information, and we look forward to hearing any comments or feedback or questions you might have about the 2024 FDM and about FDM 202 in particular. Thank you very much.